So, welcome to the lecture on design for assembly. We initially saw design for assembly, design guidelines for different modes of assembly, then methods for evaluating design for assembly. In this lecture, we will be more focused towards design for disassembly, disassembly process planning, disassembly sequence planning for a product with defective parts, reasons for not implementing DFMA. The definition for disassembly: in the modern era of environmental awareness, end of life objectives such as component reuse, remanufacture, recycle constitutes some of the most important reasons for disassembling products. So, earlier it was thought of only from the maintenance point of view. Today we are more focused towards component reuse, remanufacture and recycle. So, in order to optimize the utility of the material or the products or components, we are more focused towards reuse, remanufacture and recycle, because the entire manufacturing domain moves towards or is talking towards sustainable manufacturing. This can be attributed to a staggering impact of industrial and domestic waste on the environment. If you go ahead with the same definition, if you want to pictorically represent, you can have it as primary producer, then you have remanufacture, in which we try to manufacture, and then we do reconditioning in the workshop, and then finally it goes to the end of the product. So, we use all these things to try to reuse the material which can be salvaged, and we go towards the end product. So, depending for disassembly, depending on the extent of disassembly, non-destructive disassembly can be further classified into two categories. Please understand non-destructive disassemblies. Destructive disassembly means you damage the part and then you do melting or remelting or smelting. So, total disassembly, disassembling of a product is done into its constituent components. This may not be economically feasible due to the imposition of external constraints such as time, economic factor and presence of hazardous material. So, disassembling of a product is done into its constituent components. This may not be economically feasible due to the imposition of external constraints. This is total disassembly. Selective disassembly. Selective disassembly is a reversible dismantling of complex product into less complex sub-assemblies or a single part. So, I try to remove certain parts of the entire component is the reversible dismantling of complex product into less complex sub-assemblies or simple parts. For example, removing a tire from a car, selectively I remove it from one car, put it in the other. It involves the systematic removal of desirable constituent part from an assembly. The example which I gave you is a tire getting removed from an automobile. The stages of dismantling process plan, the product analysis. It consists of assessing the end value to be realized by dismantling the product. See, product analysis, it consists of assessing the end value to be realized by dismantling the product. Disassembly value comprises the potential of a product to be reused, its value to be recovered, risk potential as well as existing recycling technology. This is very important. Disassembly value comprises the potential of the product to be reused, its value to be recovered, risk potentials as well as existing recycling technology. So, all these things are very important. So, when you try to make an assembly analysis, it is essential to understand how a product has been put together in order to take it apart. Until I know how the product is assembled, I cannot think of disassembly, because assembly would have been done in a systematic manner. So, the disassembly also should follow a very systematic manner. In fact, when I was traveling abroad, I was completely fascinated by looking at the way people try to dismantle a complete product and then assemble it back. So, they have a list procedure. So, if there are 20 screws, they say, okay, this screw has to be done first. They have given even numbering for it. So, systematically they go and then remove all the parts, then they do whatever maintenance is it back, and then they follow a reverse of it in a systematic manner they assemble. So, if disassembly has to be efficiently done, the assembly has to be systematically done. It is essential to understand how a product has been put together in order to take it apart. This planning consists of determining the tooling requirements, very important. See, many a times we try to damage a very good part or a very good product because we do not have the tools. Then magnitude of force. Today what is happening is many of the assemblies which is done, it is all automated. So, when you try to automate it, it clearly says this is the torque you have to use, or this is the thrust you have to use for assembling this part into the product. Then time and personals. So, the skill is very important, and the time is what is the duration spent to get the output. The knowledge of functional more value components is also required. Knowledge of functionally more valuable components. Suppose you have a sub assembly, in this sub assembly you have 20 parts, out of which 2 parts are going to be very much value added part as far as function is concerned and not the cost. So, you should know this, pick up this, handle this fellow in a very proper fashion such that you can try to do the disassembly process. Usage, mode and effective analysis. Failure mode effective analysis we saw earlier, which is nothing but FMEA. Now, what we are trying to learn is usage mode and effective analysis. At most, products are disassembled after they have been put to actual use. They have been subjected to considerable wear and tear. So, the disassembly process plan, the schematic diagram goes like this. So, given product group, okay. So, you have product analysis, you have assembly analysis, you have usage mode and effect analysis, and then you have determining dismantling strategy. So, here when we talk about product analysis, we try to see the risk, we value, reuse, and then we see the recycling. Okay, we see the risk, we see what is the value when we are trying to dismantle the part, what is that we are going to do, what is the reuse component, what is the recycle component. Then when we talk about assembly level analysis, we have joining elements, we have components, and then we have assembly. Then we have usage, condition, and we have unexpected. Usage, condition, and unexpected. And when we talk about this dismantling strategies, we have non-destructive, we have partially destructive, and we have disruptive. So, these are all the process plans which we do from the dismantling point of view. So, we try to look at given group product we take, and then we try to do product analysis, assembly analysis, usage mode, effect analysis, and determining dismantling strategy. So, these are all the components which are involved when we try to do dismantling process plan, right. Process plan for fabrication, we have process plan for assembly, we have also process plan for disassembly. When we try to do disassembly, risk, reuse, value, and recycle are very important components. Determination of dismantling strategy. Keeping the basic reason for dismantling in mind is the strategy of dismantling. For example, if the product is to be recycled at the material level, disassembly need not be performed carefully. For example, I am trying to completely take the iron box or iron hollow box, okay, and inside a hollow box I have a shaft and a gear. So, if I have decided that I am going to recycle it completely at the material level, so I am going to melt it and then try to make a fresh billet or a bar, whatever it is. So, then I do not have to spend lot of time in dismantling the shaft and the gear. So, that I spend lot of time and then I try to extract in the material level. Since only the intensive properties of the component are important, destructive disassembly may be used to quicken the process. So, here what I do is I try to shear it, hammer it, break it and bake it into small pieces such that when I do casting, the surface area to volume ratio is minimized or maximized, I start getting the output. So, to minimize assembly work, so similar elements need to be combined in a group, which we saw earlier also. This will try to reduce the assembly work. Material variability should be minimized to predict disassembly procedures with a degree of certainty. As far as the possible, compatible materials should be used to facilitate disassembly. Compatible materials. So, materials, when we try to apply force, it should shear. Any harmful material, if functionally important, should be grouped together into sub-assemblies for fast disposal. Any harmful material, it can be polymer, it can be radioactive material, if functionally important, should be grouped together into sub-assemblies for fast disposal. So, this is also very important when we look at dismantling. Any valuable, reusable and harmful parts need to be easily accessible. Keep this in mind. Any valuable, reusable and harmful parts should be easily accessible. So, it should be something like a container, I pick the container, throw the container, I am done with the job. This saves a lot of time and efforts trying to reach the part in questions. Aging and corrosive material combination need to be avoided. So, if a material undergoes both the cycles simultaneously, it is going to be a deadly influence. So, aging and corrosive material combination need to be avoided, since disassembling them clearly and efficiently is a big challenge, often is difficult. These two are very important points. Please keep it in mind. When we talk about assembling, we should also think of product architecture. Product architecture means placing of the sub-assemblies at spaces such that it can be accessed and it can be replaced very fast. Okay. What is said in the preceding point holds equally true as far as the protecting sub-assemblies from corrosion, the reasons being the same. The product recovery approach. The objective in the product recovery is to recover as much as possible of the economical as well as ecological values. Economical and ecological. Today we are talking about green manufacturing, damage to Mother Earth. So, economical as well as ecological value of the product, component and material, so that to minimize the ultimate quantities of waste. So, the biggest challenge is how to reduce waste. Reduce waste is a big challenge. So, options for product recovery after disassembly. Option 1 is repair. The objective of repair is to restore a working condition. Level of disassembly, product level, limited disassembly and fixing. Results, some parts are repaired. Cycle repair, restore to the working condition. Product level, remove a nut, put a nut, axle has to be removed, spokes has to be replaced, the bearing has to be replaced, bell has to be replaced. It is all just working on one part, repair the part, put the part into action, and then you can start using it. Refurbishing, which is very commonly used in online purchase. If you see cell phones, they say refurbished cell phones, refurbished products. Improve to quality level, though not like new. Improve to quality level, this generally happens while producing the part. If there is a small scrap involved, or if there is a small damage which is involved, or you have used a series of batteries of, in the sense, a battery series means a number, a batch number you have used, and you have found out that while quality checking they all have given some problems, then the entire product is quarantined. So, now what the company does is take those parts, products, and then replace those batteries and then start selling it once again, and they put a stamp saying that it is a refurbished part. So, improve to quality level, though not like new. Modular level, I said battery is a modular. Some technological upgrading, maybe a software upgrading, also refurbishment. So, some modules repair or replaced. Remanufacturing, restoring to quality level, where the part level we try to do it and then we try to replace. Used and new parts in new products will be done when you try to do remanufacturing. The next one is cannibalization, limited recovery. Cannibalization is limited recovery, selective disassembly and inspect of potential reusable parts. Parts reused, recycled or disposed of. Cannibalization means selective disassembly, and once you disassemble a module and then look at the module or a sub assembly and look at part level and see what all can be reused, recover it from there and then put it back and then start using it. See, cannibalization many a times happens, say in hostels. What happens, you have lot of furnitures which have to be reworked, some it goes beyond the condition of rework. So, what we do is we extract material from each cot, from each table, from each chair and try to assemble it and make one more chair. So, this is cannibalization. So, cannibalization means limited recovery and 100% cannot be done. So, we recover from 10 parts and then we make one product. Then recycling is reusable material only, material level it is done. So, if you look at it product level, module level, part level, selective disassembly and material level. Look at the levels, how it goes. Recycling works on material level. Materials used in new products. For example, we try to take a plastic bottle, shred it, we go back to the pellet form, then make pellet form, and then you can make one more bottle. So, that is shredding and making one more bottle. So, these are the different options which are available as far as product recovery approach is concerned. Now, when we talk about green manufacturing, this is all major component or major concepts or technology which is used. So, these are some of the options for recovery: repair, refurbishing, remanufacturing, cannibalization and recycling. So, disassembly sequence planning for a product recovery. The disassembly sequence plan DSP is a program of tasks that begins with a product to be disassembled and terminates when all the desired parts of the products are disconnected. So, this is the definition for disassembly sequence plan. You buy a car, remove the car part by part by part by part. Okay? That is called as disassembled and terminates when all the desired parts of the product are disconnected part by part by part. A DSP aims to optimize product recovery through the minimization of cost, maximization of material recovery and minimization of disassembly time. One is cost, time and material recovery. These are the optimized products recovery through. These are the optimization techniques which we use, or the constraints we use, not the techniques, constraints we use. One is cost, another one is material, and then maximize material recovery and minimize disassembly time. A DSP uses mathematical techniques such as linear programming, dynamic programming and graphical tool for doing it. For example, I have been working with the problem of recovering or recycling lead acid batteries. Lead acid batteries are more used in UPS, that is uninterrupted power supply. It is used in cars. So, all these batteries are 90% or even people claim 99% recoverable. So, we try to look into the cycle, how is this entire cycle working on. So, when a customer buys, he uses it. When he tries to sell the used batteries, what is the costing he get, what is the policy which is there for the entire recovery of the lead acid battery parts is a big challenge. And people have started working on it, because the policy decisions has to be made. What percentage of discount has to be given to the customer when he tries to buy a new product. When he gives the old battery to me and buys a new battery from me, what is the discount? And when it is getting into recycling, what will be the cost recycling person gets from the manufacturer. So, it is a very, very interesting problem. Product recovery approach is very much talked today. For example, when you are trying to discard your automobile, bus, truck, car. So, what happens to the overall recovery? For example, if a car is to be salvaged, if a car is to be sent for recycling. So, how much percentage of parts come for recycling? What is the recycling procedure? What is the energy we apply? At every level, what should be the costing? Who gets this costing? And at last, from the product, what is the amount of waste getting generated? So, it is very interesting, and government is pushing to do lot of study on this recovery. So, the dismantling, disassembly sequence planning for product recovery, 3 distinct types of geometric assemblies can be defined. So, first is type 1, any assembly having a main component to which other components or sub-assemblies are directly or indirectly assembled, they are called as type 1. Type 2 is any assembly having no main components, all components are assembled with others. This can be disassembled only as a single component is called as type 2. Type 3, an assembly that is a combination of both of these types, this is called as type 3, and this can be disassembled as further components. This is called as type 3. So, type 1, let us take an example of a car, an assembly having a main component to which other components or sub-assemblies are directly or indirectly assembled, for example, engine. Okay. An assembly having no main components, all components are assembled with others. This can be disassembled only as a single component, a tire and a rim. So, when you have a mixture of these both, it is type 3. Three kinds of sequences driven by disassembly caused and analyzed on formation of the disassembly tree. Type 1, target disassembly sequence. Specific components are disassembled to remove valuable components. For example, you try to remove some 10 bolts and nuts and you recover a complete engine. So, target disassembled sequence. Optional disassembly sequence, disassembly is stopped when marginal returns on the operation becomes uneconomical. You keep removing till a time that you know that these are the parts, when you try to dismantle it, you are not going to make a money out of it, stop there. So, that is disassembly is stopped when marginal returns on the operation becomes uneconomical. That type 3 is a complete disassembly of a product, is complete disassembly sequence. So, you have target disassembly, optimum disassembly and complete disassembly. All these things are disassembled keeping the optimization parameter as cost or time. So, cost and time can be linked. Disassembly sequence planning for defective parts in a product. Changes in disassembly sequential planning have to be incorporated to handle factors leading to uncertainty. So, incorporating to handle factors leading to uncertainties. Availability of original CAD drawing and an unchanged product structure has been assumed. So, these are all for defective parts. These are all for defective parts. Please note it down. Availability of original drawing and an unchanged product structure has been assumed. Okay. Next is the physical relationship among components is represented using the disassembly precedence matrix developed from the original CAD model of a product using and relationship. Next, an optimum disassembly sequence planning is generated. So, this is all for a defective parts in a product. So, when we try to draw a schematic diagram for disassembly sequence planning for defective products, first what we do is we generate disassembly sequence plan. How are we going to remove? Next, it is going to be DSP, disassembly sequence plan for perform disassembly. Then it is going to be paths to remanufacture. When you want to understand what is remanufacture, please go and see the options which we went through now: cannibalization, recycling, remanufacturing. So, those things. So, parts to recycle. So, these are all performance disassembly. So, here we modify disassembly sequence plan, and this is the incoming products and this is the current part in DSP defective. Okay. This is modified DSP. DSP is disassemble sequence plan. Okay. So, it is generating disassembly sequence plan. So, then the plan is given here, performance disassembly is carried out. So, you try to separate out remanufacturing, recycling, and then it is modified disassembly sequence plan is done. So, this is given back. So, again this gets reiterated and we start doing it. So, here is directly from the incoming product where disassembled parts can be or products can be put for. So, evaluation of disassembly plan. Disassembly cost must be justified by the economic advantage of recycling. Recycling costs and benefits differ for specific fractions of recovered material. Recycling costs and benefits differ for specific fractions of recovered material. So, type of recycling according to the component composition, we have primary recycling, secondary recycling, tertiary recycling and quaternary recycling. So, primary recycling is defined as recycling on a comparable quality level. No alloy present in the component, polymer content in the component is taken care. So, secondary recovery, recycling on a lower quality level, downcycling, presence of an alloy in the component, no polymer content, ceramic content, elastomers and composite materials. So, these are all the component composition, right. Then ternary recycling, complete decomposition, no polymer content or ceramic, and quaternary recycling is inclination with energy retrieval. So, this is like biomass, inclination with energy retrieval, again the component composition will be no polymer or ceramic content in it. So, reasons for not implementing DFMA, design for manufacturing and assembly, not invented here. In general, any proposal to implement DFMA should come from the designers themselves. If the designers do not come, then it is good for DFMA, it is going to be very difficult. Next is no time. Designers are usually constrained by the urgent need to minimize the design to manufacturing time for a new product. So, that is why no time. So, this tries to put a major restriction for implementing for DFMA. So, the ugly baby syndrome is involve the designers in the analysis and provide them with the incentive to produce better design. So, designers getting involved in the analysis. So, while analysis they know where the failure is, how to retrieve the failure or how to improve the product and other things. Low assembly cost. Description of the application of DFMA shows that the first step is a DFA analysis of a product or sub-assembly. So, the low assembly cost also tries to put a restriction from going to DFMA. If the production volume is low, then also people do not prefer for going for DFMA, because DFMA needs a critical batch size in terms of numbers. When the product is manufactured in large quantities only, then DFMA is worthwhile. The database does not apply to our product. In need of unique database, everyone seems to think that their own company is unique. So, this is the other thing which companies do not apply DFMA. We have been doing it for years. So, this is a typical mindset which is there amongst industries, that they do not look for implementation of design for manufacturing and assembly. When this claim is made, it usually means that some procedures for design for producibility has been in use in the company. Okay. Design for producibility is used in the company. It's only value analysis. It is true that the objective of DFMA and value analysis are the same. So, this also puts a restriction of implementing DFMA. The reasons for not implementing DFMA: DFMA is only one among the many techniques which are available. So, since the introduction of DFMA, many other techniques have been proposed. For example, design for quality, design for competitiveness, design for reliability, design for repeatability, and many more. If you look at it, defects per million parts, okay. So, these are in million parts. These are the manual assembly efficiency DFMA index. You see that when the efficiency is very high, 60%, when the parts defects part produce is 1, when the manual efficiency is at 60%. When the manual efficiency goes down, so that means to say there are many mistakes done. So many defective parts are produced per million. Okay. So, this is an index which clearly says why we should go from manual assembly to automatic assembly. So, if it is one defect, the manual efficiency is 60%, so per million. So, the last note: survey taken at engineering design reveal somewhat surprisingly that reduction in product manufacturing cost is not necessarily considered to be the most desired outcome of redesigning efforts. This is what I understand, and this is what I have collected from several literatures. Another advantage is that DFMA provides a systematic procedure for analyzing a proposed design from the point of view of assembly and manufacturing. DFMA tools also encourage dialogues between designers and the manufacturing engineers and any other individuals who play a part in determining final product cost during the early stage of design. This point is very important. This is why in concurrent engineering we try to the discussion, whatever it is, DFA, DFMA is all used. Okay. So, determining the final cost of product cost during the early design stage is done if DFMA is implemented. So, to recapitulate what we saw in this particular lecture series of design for assembly and disassembly: what is design for assembly, what are design guidelines for different modes of assembly, different methods for evaluating DFA, design for assembly, design for disassembly concepts, what is disassembly process plan and different types in it, disassembly sequential planning, major reason for not implementing DFA. These are some of the titles or topics or contents we saw in this lecture. So, tasks to students: take a ball point pen, okay. Try to disassemble the pen to material level. Try to measure the weight and also approximate cost for every part. Certain parts can be reused, can be recycled, can be remanufactured. Please make the list. Okay. After doing all these studies, now try to manually assemble the pen back and evaluate its functioning. You will see lot of challenges will be there, and it will be very surprising to see many a times it will not even function. Then on top of it, when we have made parts that can be recycled, so now you have stripped it to the last mile, right, to the material level. Now you will try to make a list of sub-assembly technique used in the parts, or now try to make a list of sub-assemblies in the pen. Try to design a fixture for assembly and disassembly operation. You can take ink pen. I have said ballpoint, you can also take ink pen. So if you are more conversant with ink pen, please do it. Try to disassemble, then assemble, try to make a fixture such that you exactly make it to the requirements. So once you start doing this complete exercise, you will start realizing what is assembly, what is systematic assembly, what is disassembly, what is the systematic disassembly, what is the economical viability level till where we can go disassemble parts and see. And after you do that, how is the concept of recycling, reuse and remanufacturing applied in the pen as a product. Okay. So, thank you very much.